Hi all, welcome to Cracking the FAANG interviews. Today I'm going to be talking about an interview question that's recently become very popular in FAANG companies. It's been asked at Amazon and Netflix. The question is finding a common element in three sorted arrays. So what we are given here are three arrays. Let's call them A1, A2 and A3, and we are expected to find a common element in these three. If you were to implement this, let's ignore the word sorted for just 1 second. And if you were to find a common element in three arrays, the way you do it is using a brute force technique where you'd have a I loop. You take one element in the first array and you'd scan every element in the other two arrays to find a common match. With three pointers I, j, k, your time complexity for that brute force method would be O of n cubed. Now, we've been given that these arrays are sorted. Can we use this property to do better than O of n cubed? That's the crux of the problem. We'll look at it in more detail with an example in the next slide. So I have a snippet here from Geeks for Geeks, and we've been given three arrays here. Array 1, array 2, array 3. We can use I, j, k for indexes for each of these arrays. And what we need to do essentially is check for common elements. So in this example, 20 is a common element between the three arrays. So is 80. Now the question is, how can we implement this efficiently? And find the common elements in all the three sorted arrays. So sorted arrays have a property where if you are at a particular element, you're able to compare the two elements, all the three elements in this case, and decide if this minimum element is present in the other arrays or not. The way you do that is you look at A1 where there is an element 1, A2 has an element 6 and 3. What this tells you when you start is, or when you are at in a particular iteration, is A1 has 1, but A2 has the first element in A2 is 6 and the first element in A3 is 3. So neither of the other two arrays have A1. So what you do is increment the pointer with the smallest element of the three arrays. So what I'll do in this case, if I is at index 0, I'll move it to index 1. Now in this step, what we do is we compare this again. So we have 5, we have 7 and 4. If A1 has 5, A2 has 7 and 4, we know by comparing these three elements that 4 is not present in either A1 or A2. But 5 can be present in A2. 7 can be present in A2. Since we are at 4, the next element could be 5 or 7. So what we do is increment the smallest element again, which is k, and go to the next index. So we are at 15 and so on. So once we do that, we reach index 20 and we reach the same element, and we'd be able to flag this is common right now. All right. So let's look at some code in detail. So we have the three arrays as input here, array 1, array 2, array 3, and we have n1, n2, and n3, which is the size of the three arrays. And we initialize the 3 pointers of the arrays to 0 index, meaning we start at the leftmost point of all the three arrays as we saw in our example. And we have this one loop which goes through all the three arrays at once. And what you're doing is, if you found a common element between all three arrays, where array 1, array 2, array 3 respectively their pointers point to the same element, you print out that element and you increment all three, because you've taken that snapshot 20 in our previous example and you want to move on to the next one. But if the other case is array 1's element is smaller than array 2. What does this mean is you can just ignore that element. It's not going to be present in array 2. Hence, It's not a common element. Same for between array 2 and array 3, you increment j, and if either of these three conditions aren't true, you just increment k, which means the element in k is the smallest. So the idea is to get rid of the smallest because it's not present in the other two arrays. And the time complexity of this is going to be O of n plus m plus k, where I'm assuming k is the number of elements in the third array, or with the code notation that we saw here, it's O of n1 plus n2 plus n3. So this is a linear time code compared to what we had earlier, which was cubic time complexity, which is a great improvement. And the only way we are able to do this is because all the three arrays are sorted. I hope you enjoyed this video and thank you for watching. Stay tuned.